chapter today. Over the course of the year, the many students I've had, most students usually find this the easiest one of the whole year. You'll notice it's not very thick, right? So it's a very small chapter. I've broken it up into 2 parts. So today we're starting the first part, and we'll be done this sometime in January. Towards the end of January, we'll be done it. There's only 3 lessons. It's not very big, but we're, there'll be assemblies in the way. There'll be little on exam we do. Yeah, I think there's assembly this Wednesday. I'm not sure if it affects our class, but there's assembly this Wednesday, right? So we'll be done sometime in January here. Most people do really, really well. Today's is the day that is going to require the most concentration from you guys. Right? So, this is pronounced polynomials. Yes, please.
What's the assembly about?
I don't know. Right? So, this chapter is pronounced polynomials. It's a brand new concept for you guys. So we're starting at the basic levels, and today is more about definitions and what these things are. Okay? All right. So now, make sure you have your name on it, and we are in block B. Dhaliwal. B. All right. So let's get started. So now, students at the beginning often look at this and get intimidated. All right? I said, hey, usually your best mark comes from this chapter. Right? We have these things called polynomials, and if you look across the page, you see a whole bunch of numbers and letters and plus and minus signs and all over the place. It can look intimidating because you haven't seen this kind of stuff before. Not too bad. Right? We're going to break it down and tell you what everything means. Right? Now, first thing students don't like is the letters. Letters are just a placeholder for a future number. Unknown numbers are our letters. Right? So, don't worry, that's just a spot for a number. In grade 9, we don't really use them too much. We'll use the letters every once in a while, but not too often, right? Now, all of these things are what we call polynomials, and you need to be able to name them. That's a generic term, polynomials. So you need to be able to look at all these different kind of expressions and tell me what the name is, right? So you have to memorize 4 names, right? And so there's, how do you tell the name of these expressions? Is you need to count these things called terms. A polynomial is made up of something called terms. And you got to be able to look at these expressions and tell me how many terms there are. And it's not that hard to do. Right? The hard part of this chapter is keeping all these definitions straight in your mind. There's lots of new words that are coming your way. So now, terms is just the math way of saying parts. You look at this expression, you go, how many different parts are there, right? So now, to do that, we take an expression and we split it at the plus signs and the minus signs. So at the addition signs and at the subtraction sign. That separates the parts, the terms. So if you look at this expression here, right, what I like to do is with students is say, hey, just draw a big line through the plus or minus signs here. We see like a line through there and a line through there, like that. That really highlights how many parts there are. If you look at this expression here, you have 1, 2, 3 parts. Okay? So the math word for saying parts is terms. So we say this has 3 terms. All right? Now, the number of terms tells you the name. So if it has 3 parts, 3 terms, anything with 3 parts or 3 terms, it's called a trinomial. So looking at this example here, if I split at the plus signs and the minus signs, I split here. Oops, that moved on me. Come on. So you want to come back? There we go. We're going to split here, and we're going to split here. That gives us 3 parts. So anything with 3 parts, it's called a trinomial. Right. So spelling does count. Usually on the page, I will give you the words. You gotta make sure you look it up and use it, write it down correctly. So that's called a trinomial. Now, if something has two parts, like the question above, right? You go like this. We split at the minus sign here, and you got a part here, and you got a part here. So two parts, right? And that one's called a binomial. Right? Trinomial, binomial, right? And if you look at the one above that, it doesn't have any plus minus signs to split this things apart. It only has one thing here, and that's called a monomial. Monomial. Right? So you need to know these words, memorize them. The spelling usually be on the page. Right? But you need to know what these stands for. Now, the way my mind works, may work for you guys, I think of like a bicycle to help remember these. So all of these end with nomials, right? Then the beginning is what's changing. Like a three-wheel bicycle, tricycle, trinomial. Bi means two. Two-wheel bicycle, it's called a bicycle. And the only one the bicycle analogy kind of falls apart with is a one-wheel bicycle. It's called a unicycle, but monomial. It's not a perfect analogy, but hopefully that helps with you guys, right? So, tri means three, bi means two, mono means one, and the nomial part stays the same. Okay, so now those are the names you have to memorize. Now, every single expression does have a name, right? But we don't have to memorize them. Now, if you look at the next one, I split this up at the plus and minus signs. We have 1, 2, 3, 4, 5 parts. For the purposes of grade 9 and grade 10, anything more than 3, we just can call it a generic name. The generic name is a polynomial. So, right? So the word generic name is polynomial. Right? That's the name of this chapter. And I'm hoping that the word poly you've seen before, maybe in your science class this year. Polyatomics, right, which means many atoms, and this just means many terms. So the word poly just means many, right? So it's all connected together, right? Okay, so we're going to practice this. All right, so going over here, all right, here we go. We're just going to list the terms. We'll do the names first, second. All right, going for the first expression here. How many terms are there? Yes, Thomas, thank you. Just one. Next one, how many terms do you see? 3. Good. We split it here and here. So 1, 2, 3. All right. Next one, how many terms do you see? 2. A split right here and 1 part, 2 parts, 2 terms. Okay. Next one, 2. Thank you, Thomas. Split it here, right? 1, 2, right? Next one, you can't split it. 1, last one, 3. Thank you. We got, which color haven't I used? I haven't used blue yet. Come on. 1 there, and we have 1, 2, 3 parts, so we have 3. Okay. Now, just look to the left side. I'm not going to ask you as a class to name these things. Just practice writing the names down. It'll help with the memory, right? I'll write it down and give you a couple of seconds head start. Write down the names. 1 term, monomial. 2 terms, binomial. 3 terms, trinomial. Just practice writing it down, right? It'll help with the memory, right? So this is monomial. Meal. Meal. Try no. Not too bad. Okay. So I'm hoping you don't find it too difficult. Right, so what's going to happen on the assignment, it's going to feel more difficult. Is when I ask you the same question in 3 or 4 different ways. Right? So that's what makes the assignment feel difficult. We're going to do assignment today. It's going to be relatively easy, but you just got to keep all of these things straight in your mind. So to figure out the name of an expression, we got to count how many terms they are and then come up with a name. Not too bad. Okay. So now there's a characteristic that you need to know. So each of these terms have something called a degree. Okay. Now, in grade 9, you are not going to get tested on what a degree is, right? You just need to be able to figure out what a degree, what the number is for the degree. Okay. I'll give you a sneak peek of what a degree is, right? I think it's helpful. So in grades 7 and 8, we do a lot of graphing. We're going to do graphing in grade 9 as well. And the way we do it is we make a lot of points, and you graph all the points, and you have your picture of your expression, right? That takes a long time. So what we do going forward, and you learn that somewhat in grade 9 here as well, is sort of coming up with a whole bunch of points. We figure out the properties of these expressions. And using the properties, we can sketch how the graph looks like. So now, one of the things, so not until grade 11 do you actually start using degrees. So if something has a degree of 1, it's going to have a graph that looks like this. A line going up or down, right? And if something has a degree of 2, like, you don't have to memorize this. It's not going to be on our test. It's going to have a U-shaped graph. A graph like this or a graph like this. If something has a degree 3, it's going to have a graph like this. Or a graph like that, right? So just by looking at it, you can sort of visualize what a graph looks like, right? That's the way we're going. We're not going to go to graphing all these points. You're going to go by properties, right? And that's where we're headed. And this year, we're just looking at, okay, the baby step. What is a degree? How do we figure out what the number is, right? How do we know this is a degree 1, degree 2, degree 3, right? What we do is we look at the exponent of the variable. Look at the exponent of the variable. That's a word I haven't defined yet, but I mentioned it before in the past. What is a variable? Does anybody know? So if we have expressions, all these expressions are full of numbers, plus signs, and minus signs, and letters, right? The variables are your letters, okay? Variables are your letters, all right? So we look at the exponent of your variables, of your letters. So we have 3 examples here we're going to look at, right? Easy and a little bit of trickiness in there. So our first example here is we look at the x and go, what's the exponent of the x? You don't see anything there, but we talked about it. If you don't see an exponent, there's an imaginary number there. What's that imaginary number? 1. So this has an exponent of 1, so it has a degree of 1. If we were to graph it, it'd be a straight line that looked like this. Right? Actually, that one would be the one going up. Right? Next one. We run into a situation here. Right? We have 2 letters. We have an X and we have a Y. What do? So if you have more than 1 letter inside of a term, the rule is you add the exponents together. See, if you have more than 1 letter, you got to add those exponents together, right? So here, the X has a 2, the Y has a little imaginary 1. So overall, 3. This has a degree of 3. Okay, last one, the 12. What's the degree here? Not 2. June?
Can you go back a bit?
Yeah. So remember, we're trying to find the letter, then the exponent of the letter. What's the letter here?
0.
Yeah, there is no letter, so there's no degree. So this one has a degree of 0. And I didn't draw that up here, but if I drew anything with a degree 0, it would be a flat line going like this. Right? Which should make sense. The value is 12, always 12. So it's going to be a flat line always going like that, right? So we need to be able to find the degrees. All right? Now, let's practice this. Actually, not on that one. I should have done more practice questions for that. This is the part where students start getting things jumbled up in their head. Yes? You need to do this, right? Okay, so now a term has a degree. But we have these things, they're polynomials, right? This polynomial is made up of a bunch of terms. So what's the degree of the polynomial? Right? So a term has a degree, but a polynomial does as well. So the rule here is you need to find the degree of each of those parts. That's the first step. Right? So you split this up into 3 parts. And you go, okay, what's the degree of the first part? 2. Degree of the second part? 1. The x has a little 1. Degree of the last part? 0. No letters. 0. Now, the rule is, for a polynomial, you find the highest degree. And that's the degree for the polynomial. So we look at 2, 1, and 0. The biggest number is 2. Right? And what the issue usually students happen is they want to add these numbers together. Because that's what we do with the degree, but you don't do that. Right? For the polynomial, we just pick the highest one. So what a degree does is I told you, hey, it tells you what the graph looks like. Right? So each one of those terms kind of shapes how the graph looks like. The one with the highest degree has the more overall powerful characteristics. And that sort of dictates how the graph looks like. So this graph, if I graphed it, it would look sort of like a U shape, but maybe more split out because it has like a degree 1 in there as well. Yes, Thomas?
For example 2, like on the 3D2.
The 3D.
On the
Oh, yeah.
second part, on
Okay.
the
Okay.
5xy, would that just be 1?
We're getting there. We're getting there. Okay, we're going to go there next, all right? So next is state the degree of this expression. So we need to split it up into terms, find the degree of each term, and pick the highest one. So the first one term, what's the degree here? 2. Right? That's not too bad. Right? Next one, terms, 1 line there. We have 3 terms. 1, 2, 3 terms.
2.
The overall degree is 2. You're right. So you got to find the degree of each part. You have a 1 here, you have a 2 here, and a 1 here. So the biggest one is a 2. How many terms are in the second part? Sorry, third question here. Nope. Terms. 2 terms. We split here. What's the degree? 1. The first one has a degree of 1. The second one has a degree of 0. Overall, it's 1. Next one. How many terms? 2. Right? We split it here. Degree of the first part? 2. There's only 1 letter there. Degree of the second part? 2. The x has a 1 and the y has a 1. We got to add those together. So overall, the highest one, 2. Okay. R, what's the degree here?
2.
Not 0.
Oh, there's 1.
1. There's imaginary little 1. Okay. Last one. How many parts are there? 3. We split here, we split here, okay? And the degree of each of the parts. First part, 2. Middle part, 1. Last part, 0. Highest, 2. Okay? So the hard part of this chapter is keeping all of these things straight in your mind. And there's a couple more words I'm going to throw at you. Right? You sort of come across them. Right? One of them might be the word coefficient. So if I take, say, an expression like this, 5d squared. And I say, hey, what's the coefficient of this? We talked about this back in the exponents unit. What am I asking for?
2.
Not the 2. The 2 would be the exponent. The d would be the variable. The 5 is your coefficient. A coefficient is your number in front of your letters. Right? So this is your coefficient, right? Coefficient. The number in front of the letter. So I could go, say, to the very last question here. I could say, hey, for this last expression, I could say, hey, look at the second term. What's the coefficient? 2. But you also have to include the sign. So negative 2. So coefficients can be positive or negative, so you include the sign. So the coefficient here would be negative 2. How about the first one? What would the coefficient be here?
0.
Not 0.
1.
Yeah, if you don't see a number in front, there's an imaginary 1. So coefficient here is a 1. Now, that's 7 there.
Can you
Hmm?
zoom out?
Zoom out, I can. Yeah. That 7 is not called a coefficient. Coefficients come in front of the letters. That one doesn't have any letters attached to it. So if you have a number all by itself with nothing else attached to it, it's called a constant. Right? So this is called a constant. A number all by itself. So that's what makes this thing hard. There's like lots of new words for you guys. It's not easy. Right? And on the assignment, I'm going to ask you the same questions over and over again, different way. What's the degree here? What's the name? How many terms are there? What's the coefficient? What's the variable? I'm going to ask you the same question in like 7 different ways. Right? I can only ask you those things, but it can look so much different. All right. The final thing for today, before we work on our assignment, is this thing. All right. Now, you'll have 1 or 2 questions like this for me. I only do it because sometimes it shows up in grade 10, depending on your teacher. So, some people like to teach with symbols, right? So you got to know how to change an expression to a symbol. So if I say this expression is this set of symbols here, can you tell me what each one of these symbols means? We have big squares, we have rectangles, we have small squares. What do the squares and the rectangles mean? Can you kind of look at this and like at this and sort of figure out what each one means? Hmm? Yeah, but what? What does this represent? What do the big squares represent? What do the rectangles?
The first number.
You're on the right track.
So 1 hole.
Yeah, so I'm glad that you're sort of noticing, hey, I have 2 here and I have 2 there, right? They're connected, so the giant squares are x squares, okay? The rectangles here are x's. That's what it means. So here we have 4 x's, we have 4 x's. And the last one, and do that in green, these are our holes. We have 1, 2, 3 holes. All right, so you got to know that. I'm going to give you a diagram, a legend with that, so you don't have to memorize it. So now, we know what each shape means, but there is a color difference. Some of them are black, some of them are white. What does a black mean, and what does a white mean? Positive and negative, right? So you notice the black ones are the positive numbers, and the white ones are the negative numbers. So those are actually negative x's. There, okay? So on the back side, I've got all this labeled for you. You don't have to memorize it on a quiz or a test. I'll give you what each one of these things stand for, right? So we're going to just practice working with this, right? So over here, I've told you what everything stands for, and we're going to write down the expressions. So going over here, right? You got to imagine your expression, right? You got to go, okay, how many terms does this expression have? And come up with those terms. Like for the first one, so each shape is a term. We split at the term here. We split right here, right? We go, okay, we have a term over here, and we have a term over here. So we need to come up with an expression with two terms. What is the first term? What does this symbol mean?
Negative 1.
Negative 1, x. So negative 1, x.
You always have x.
You always have to put the x. The 1, you may be optional, right?
Why did you put the 1?
Huh?
Why did you put the 1 if you're writing the formula?
The 1, you don't need to show the 1. I'll show you the optional way in a second, okay? Then the orange part, 3. And we need to show if it's positive or negative, so the plus 3. So now with coefficients, you don't have to show 1s. So this whole thing could be rewritten as negative x plus 3 like this. So the 1 coefficients don't have to be shown. Right? So the next one, looking at question B here. Each shape separates a term. So we'll separate here and separate here. So we have 3 shapes. So our expression is going to have 3 terms. What's our first term? 1 what? 1x2. Second term? 1x. And it's positive, so you put the plus sign in there. Right? Our terms need to be separated by a plus sign or a minus sign. Our last term. What would that be? Minus 2. They're white, so they're minus. All right? So now, the optional way, because you don't have to show 1 coefficient, this could be x squared plus x minus 2. Both are acceptable answers. This is what most answer keys will look like, because you don't want to show extra information. That's not necessary, but both are acceptable. All right?
So you don't have to put the 1?
You don't have to put the 1. If it's any other number other than 1, you have to show it.
Okay.
Yeah, but you have to show if it's positive or negative. Right? So the next one, we're going to split this up with the shapes. Split and split. So we have 3 parts again. 1, 2, 3. All right. What's the first part?
2x2.
Close. Minus negative 2x2. They're white. So we need the negative part in there. The middle one. Negative 3x. Excellent. Those are x's. And positive 4. Plus 1. All right. There we go. All right. Last one. How many parts? 2 parts. We split right here. All right. First part. What is it? What term is it? 2x2. They're black, so they're positive. Last part. Negative 5. Minus 5. And that's it. Yep, go for it. That's it. Now, as for your assignment, on the first page, I've given you most of the answers on the whiteboard, just so you sort of know how this works. By the second page, it's the same kind of questions. I just haven't given you the answers. Right? We'll go over it next day. That's it.